Hello YouTube, my name is Leo. I'm a sports scientist and a strength coach. This is my first video ever on this channel. The idea is to pretty much show people how we can use Matlab to analyze sports science data as opposed to Python and R, which are being used extensively within sports science. Matlab is probably used a little bit less. Maybe it's isolated more so among engineers. So just to keep this video short, let's talk a little bit about the aims of this first video. Just some basic stuff. We're going to be importing c3d files in Matlab. We're going to be using this function called uigetfile, and then we're going to be talking about a biomechanical toolkit called BTK. Okay, so once you have your Matlab open, now optimally you would have your script within the file itself, and then I also have my path set here to the folder out of which I'm working. And let's get right into it. So we mentioned the uigetfile function. So let's talk about what you would feed into the function itself. And so what you would normally do here is feed into it some sort of a path, right? And that's exactly what this is, right? The path to this folder. And then additionally, what I did is I put an asterisk and then .c3d, and all that does is pretty much ignores all of the other extensions, with the exception of the c3d files that are in the folder. And you could always be a bit more specific, and if you just want, let's say, the counter movement jumps. So I have 4 trials here, so trial 1, 2, 3, and then the 4th trial, which I deemed to be a bad trial, right? So if I just put cmj underscore tr underscore, what that will do is that it will pull in all 4 of these guys, right? And it will ignore these 2 because we want cmj underscore tr underscore, right? And so anything that deviates out of this is not going to be recognized, and so it's just gonna make these 4 files available. All right, and then furthermore, this first property is pretty much just the title that will come up at the top of the dialog box when you run this. And then this multi-select on feature is one of those features where it will allow you to select multiple files, and so we're going to have that on. And then we want to assign this to this is pretty much going to be a cell. So we have a cell here called file list, and then we have the path here, and we could always take this out because we don't really need it, so we'll just go ahead and put file list. And then that's really it. Last but not least, this will probably become a little bit more important later on. For now, not so much. What we want to do here is assign the length of this file list here to this variable. And just based on what I told you, this file list is going to be 4, so this file list number should be assigned a 4 here. So let's go ahead and run this, and then so like I said, those 4 files become available, the ones that match what we fed into the path, and then I hit open, and then the file list number becomes a 4. Let's go ahead and clear the command window, and then that's really it as far as the uigetfile function. Let me go ahead and delete this and rerun this. All right, so we have the file list and then the file list number, which is a 4. And then when you move down here, now this is where you would use the biomechanical toolkit. And so what I want you to do next is go on Google and download the BTK toolkit. And you'll probably come up with this page right here. Go ahead and download, and then after you download, what I want you to do is go ahead and find where it's downloaded, and then pretty much just add it to the path. I've already added to the path, so I had to remove it, and I'll redo it here. Okay, so now instead of having like a single reading of these files, what we want to do is read all 4 of them into some sort of a structure. And so that's why we have this for loop set up here. So we have a counter variable I, which is going to go 1 through the file list number, and that file list number is pretty much 4. And we're gonna assign this first variable here, and we're going to use this function BTK read acquisition to pretty much pull the characters out of the file list, right? We're going to assign it here, and then from there we're going to get this BTK get analogs function to read in whatever's in the file name, and then we're going to get that analog data, so that's the force plate data, and we're going to make a new variable called forces, and then a second variable called forces info. And what this will do is it will pretty much create a row of the different force variables. So we'll have f of x, f of y, f of z, and then it will do the same exact thing for moments. And if you have 2 force plates, then it will have force x2 instead of x1. And so let's go ahead and run this. So if I just run that really quick, what we're interested in is this right here. So if we go to forces, so you have a row for every jump. And so this first jump, let's take a look at the vertical forces. And so you can pretty much scroll down and just see what you have. But you could also see how many rows you have here. So single column, you have 5,550 rows of data, and that should be the same for all of these. Yeah, I mean, obviously we don't need the stuff that's down here, so we'll mostly focus right here. And then forces info, what this does is, so it will give you stuff like information on the label, and then the description. So this just pretty much states what sort of force plates we're using. So if we're using AMTI force plates, the gain, offset, scale, and then the frequency. This may be a little bit important, right? Depending on what you're calculating. So this pretty much says that there's 1,000 frames of data here. And so if you needed to know like how many seconds was each trial, then you could just take that, you could take this number and divide it by 1,000. So we have about 5.5 seconds on this trial, and then yeah, a little bit more or less for the next few. All right, so last but not least, let's go ahead and plot. Let's go ahead and plot this first trial. Okay, so this is kind of a typical counter movement jump. The only issue here is that it's flipped, right? So we want to go ahead and make negatives positives and then positives negatives. And so one way to do that is to maybe assign this to a variable. So let's say variable A, and then what we want to do is negate it. And I'll close that. And then now instead of plotting this, let's plot A. Then if you go ahead and run it, we have pretty much flipped everything, right? And so what you have here is pretty much the subject standing on the force plate, and as you can see, this is just their body weight. So it just times by 9, 8, 1, and then as you can see, as they go down into a descent and then come back up, and then this would be the fly time, landing back on the force plate, and so on and so forth. All right, well, that's it for this video. I hope you enjoyed it, and I look forward to making the next few videos here.